Hello, everyone. Welcome back. We will continue to talk about bivariate analysis. This video, we will talk about the bivariate analysis between a qualitative variable with two categories and a quantitative variable is called t-test. This lecture will discuss the difference between the means of the two samples we draw from two populations. For this course, you will only to know what is t-test and how to interpret t-test. If you're interested, you can know about the background knowledge about t-test, but it's not required for 4510. So we will only discuss independent sample t-test, or we call it unpaired t-test. We will not discuss paired t-test or sample t-test. The independent sample t-test is used to determine if a difference exists between the means of the two independent groups on a continuous dependent variable. More specifically, it will let you determine whether the difference between these two groups is statistically significant. This test is also known by different names, including the dependent t-test, the independent t-test, independent measures t-test, between subjects t-test, unpaired t-test, or students t-test. For example, you could use the independent sample t-test to determine whether the salary measured in Canadian dollars differed between male and female. For the following of this video, I will just use t-test to refer to independent samples t-test. Here, your dependent variable is salary, and your independent variable would be sex, which could have two groups. Let's just make two groups here to make it easier. Males and female. Another example is there's a difference between male and females in the degree of happiness. Your dependent variable here includes two categories, and they are independent groups, male and females. They are dichotomous variable. Other example independent variable that could meet this criteria includes employment status, employed or unemployed, smoker, two groups, yes or no, trial, two groups, intervention or control, and so forth. So please note, we will not discuss pair sample t-test. I just will offer examples for independent t-test. If you are testing on the one dependent variable for the same individuals at two different time points or under two different conditions, you will use dependent t-test rather than independent t-test. So paired sample t-test examples could be when we test if the intervention is effective in reading human trafficking rates by comparing the human trafficking rates beforehand and after implementing intervention. That'll be like the two time points under two different conditions. Another example is after tax reform, if it has income disparity narrowed or widened. But for this class, I just offering an example of the independent t-test or student t-test. I know it sounds a little bit confusing, but just focus on one right now. Okay, hypothesis testing with two sample means follow the same structure as we do for one sample test. First, we write down the non-hypothesis and research hypothesis, and then we select the alpha level and then specify the sampling distribution and which test statistic to use, and then compute the test statistic and make a decision whether or not to reject the non-hypothesis. So if you are interested, I'm going to go through each steps quickly to let you know the background of t-test. To run an independent sample t-test, you need to consider 6 assumptions. First, your dependent variable is measured as continuous variable. We have discussed about this on levels of measurement. Your independent variable must include two categories. For example, employment status is your independent variable, which only includes two categories, employed versus unemployed. Being a smoker, if being a smoker is your independent variable, your two category would be yes or no. And you should have independence of observation, which means there's no relationship between the observations in each group of independent variable or between the group themselves. We didn't teach probability theory here, so it's a bit difficult to understand. But since probability theory is a foundation to understand inferential statistics, you may catch up the probability theory, what you learned from high school, to understand. Independent groups refer to the group in which there's no relationship between the participant in either of the group. So simply put it this way, you have different participants in each group. For example, if I randomly assign your class into two groups, a control or intervention trial groups, no participant can be in both the control group and the intervention group, right? So this is true of any two independent groups you form. A participant cannot be a member of two groups. Number 4, 5, and 6 of the assumption are about the nature of your study. So 4, there should be no significant outliers in terms of the dependent variable. 5, your dependent variable should be approximately normality distributed for each group of the independent variable. And 6, the variance of the dependent variable is equal in each group of your independent variable. Okay, so it's important to note here, our research and non-hypothesis to study the difference between two sample means is not the same with one sample test. With two sample tests, we compare the two population parameters. The independent sample t-test determine whether a difference exists between the two group means in the population. We want to study whether the difference between our two sample means is just a consequences of sampling variation, or it's whether it's a real difference exists in the population. So the null hypothesis for a t-test will be mu1, the population means of the two groups are equal. And the alternative hypothesis is the population means of the two groups are not equal. Or you can also rephrase them to reflect differences between the means, such the null hypothesis is the difference between the population means is 0. mu1 minus mu2 equals to their 0. And the alternative hypothesis is the difference between the two population means is not 0. Example, if your dependent variable is salary measured by Canadian dollar, and your independent variable is gender, which includes two independent groups, male and females, you can compare the average salary between males and females. In actual fact, it's quite simple to calculate the difference between two means, right? You simply subtract the mean of the dependent variable in one group from the mean of the dependent variable in the other group, which you will get the difference between the means of the two groups. However, the participants in these two groups are samples that you just selected from a larger population. It is a larger population that you are interested to study, not just those two groups you sampled. Due to very sample variability, the group means and their differences will differ for each two samples you just sampled. So as such, you need to use the data from the samples you've selected to estimate whether it's likely that the two group means will be different in the population. Put another way, whether difference between the two group means is likely to exist in the population. This is the reason why we use t-test. So this slide involves the knowledge of z-score, probability p-value, probability value, a probability theory, and hypothesis testing. So combine all this knowledge you learn from other courses. It is not difficult to understand what I will say here, but if not, it's still okay. So we are interested in finding evidence to reject the null hypothesis. The null hypothesis is no difference between the two groups. So we could have sufficient support for our research hypothesis. We will reject the null hypothesis if the probability of getting a t-value is less or equal to 0.05. Check another video if you are not familiar with p-value. So if the p-value is smaller than 0.05, you can conclude it is unlikely the two group means are equal in the population, and you can reject the null hypothesis. and accept the alternative hypothesis. If the p-value is larger than 0.05, you can conclude it's unlikely the two group means are equal in the population, and you can say, oh, fail to reject the null hypothesis. So remember, this is not the sample means. We are always referring to the population means. Next step, select the sampling distribution and the test statistic. So when you test the difference between two means, we use T distribution and T statistic. This is a knowledge you could remember or memorize. Now the test about difference between two sample means is based on the sampling distribution of the difference between the means. The sampling distribution of the difference between means is a theoretical probability distribution. Then would be obtained by calculating all the possible mean differences by drawing all the possible independent random samples of size 1 and size 2 and sample size 2 from two populations. And the properties of the sampling distribution of the difference between two sample means are determined by the central limit theorem. It assumes that our samples will draw independently from normal population. The sample size is sufficient big enough, say larger than 50. The sampling distribution of the difference between means will be approximately normal, even if the original population are not normal. In most situations, the only data we have are based on sample data. So we do not know the true value of the population variances. Therefore, we need to estimate the standard error from the sample variances instead of the population variances. And X bar represents the sample means. The denominator is the estimated standard error of the difference between the means. You don't have to memorize the formula. I just show it here to give a sense if you are interested. So actually, T statistic is a ratio of signal and noise. It considers both the difference between the two means and the variability within groups. What does it mean to say the average of two groups are statistically different? Consider the three situations in this slide. The first thing to notice about the three situations here is the difference between the means is the same in all three. But you could also notice the three situations don't look like the same, right? They tell very different stories. The top example shows a case with moderate variability of the scores within each group. The second situation shows a high variability case. And the third shows the case with low variability. So what conclusions we made about these two groups appear to most different in the low variability case? And why? Because there is a relative little overlap between the two bell-shaped curves. In the high variability case, the middle one, the group difference appears least striking because the two bell-shaped distribution overlap so much. This leads us to a very important conclusion. When we are looking at the differences between scores for two groups like male females, we have to judge the difference between their means relative to the spread or variability of their scores. T-test does this. Again, the degree of freedom, you don't have to remember this. The degree of freedom for T-test a little bit different. So when we calculate the t-test for two sample tests, we lose 2 degrees of freedom. For every population variance we estimate. So when the population variance are assumed to be equal or both sample size are greater than 50, the degree of freedom are calculated as n1 plus n2 and minus 2. So we lose 2 degrees of freedom. It is okay if you don't remember that. If your data has met the assumption of homogeneity of the variances, you simply need to interpret the standard t-test output. The next slide, I will tell you how to put things together in a single paragraph or how to interpret the results. Okay, so usually when academic articles interpret or make a decision about the results, they report the following things. The mean score is represented by M, that's a mean, and SD is the standard deviation of the samples. The t-test value as either positive or negative, and the degree of freedom is DF. The significance level used is represented by letter P at the 2 or 3 points decimal level. Okay, I know you love example. Please pause here and read this paragraph. Okay, so an independent sample t-test was conducted to determine if there were differences in self-report happiness between males and females. The degree of happiness of male students mean is 5.25, was lower than female students, that is 5.45. A statistically significant difference of 0.26, a confidence level 59%, 0.04 to 0.48. T-value is 2.365, and degree of freedom is 38 in brackets, and p-value equals to 0.023. We'll just write p is smaller than 0.05. So when they report results like this, they will say, of course, before interpreting the results, you will be familiar with the 3 levels of the p-value, smaller than 0.05, or smaller than 0.001, or smaller than 0.001. You may consider using 1 star, 2 star, or 3 star to represent these 3 levels significance in your report. Usually, when you see academic papers, they report t-tests like this. So although statistical significance difference were found between male and females in their degree of happiness, the mean difference of 0.26 has very little practical importance. This is very cautious when you read academic paper. Just because a result is statistically significant, it doesn't necessarily follow that it's practically important. Statistical significance really only indicate whether the result is not likely due to sampling error. It does not indicate how strong the difference are. It does not inform you about the size of the difference. So to overcome this limitation, the effect size can be calculated. There are many different types of effect size, with different types often trying to capture the importance of your results in different ways. So Cohen's D, which is one type of effect size that attempt to demonstrate the importance of the t-test by explaining the difference between the group means as a ratio of their standard error of the mean difference. Some publications insist on reporting the Cohen D, but it is not required for all. And confidence interval also provide information on the magnitude of the difference. I will skip this technical part. So take home message of t-test. We should use Welch t-test by default instead of student t-test. The choice will be made by the paper, and you will see different t-tests like Welch or student t-test. Because Welch t-test perform better than student t-test whenever sample size or variance are unequal between the groups, and give the same result when the sample size and variance are equal. So to save time, I would say Welch t-test, and don't waste time for the Levin's test. Okay, this is the end of t-test, and for the next video, you are going to see ANOVA.